Hello everyone, welcome back. Let us start with first compression function. Today we are going to start with hash function. So for hash function we need some definition. Let us see that. A function f is a compression function if it maps an input of finite length to an output of fixed shorter length. This is what compression function means. Okay. Computable map let me say h from x to y is a computable map if it is easy to compute the image y equal to f of h of x. Or you can see you are able to compute the image in polynomial time, complexity in polynomial time. So this is computable map. Finally, let us define hash function. We refer a function h as a hash function if it maps an input of arbitrary length to an output of fixed length. That means a function is a hash function actually. Hash function is at least compressible and computable. That means it should be easy to, yeah, here what happens are your input is arbitrary length input and you are getting a fixed output. This is what the meaning. If you see, for example, suppose I'm having a function whose image says 0, his input is arbitrary length and output I am getting say 8-bit. Okay, such that say h of say b1 b2 and so on, this is equal to b1 XOR b2 XOR, okay, where b1 is the first byte. That means I am considering first 8 characters, where b1 is b1 b2 up to b8, right? b2 is b9 up to like this. So finally whatever I will be getting, it will be a 8-bit result. If last bit bi is not 8-bit, then we add zeros to make it 8-bit. Okay. Due to this compressibility property, a hash function is minute one. Minute one function, and hence may bring collision. See, my input is of arbitrary length and my output is fixed length, so that that is compressibility here, and that's what I can find two input which will map to the same output. That's what the collision is. There are some additional properties which hash function should satisfy. First is one-way function. One-way function, this is also called first pre-image resistant. For a function say h from x to y, it is computationally infeasible. It is infeasible to find x, which is h inverse of y, for given y equal to h of x. That means I won't able to compute the inverse image of y, correct? That is computationally infeasible. This is called one-way function. One thing is weak collision resistant. And that is also called second pre-image resistant. For a given pair of xy, with y equal to h of x under a function from x to y, It is computationally infeasible. Infeasible to find a second preimage x dash such that h of x dash is y. That means suppose I'm having this x comma y pair, that means h of x is equal to y. Okay, I won't able to find a second preimage x dash such that h of x dash is equal to y. This is called second preimage resistance. Strong collision resistance, last one is. For a function say h from x to y, it is computationally infeasible. It is computationally infeasible to find two distinct values. Find two distinct values, the x and x dash. That is, I'm having x is not equal to x dash such that h of x is equal to h of x dash that is equal to y. So that is strong collision resistance. So if you see, this is very strong because here I have to find the 2 point. First of all, I have to find these 2 point and then such that their image should be same. Whereas in the case of weak collision resistance, I am given 1 point x, I have to find another point x dash such that h of x dash is equal to y. Whereas here I just have to find the pre-image. I am given both. I'm given a function. I just have to find this. Yeah, h inverse of y. I am given this y, just image. I have to just find pre-image. So for security purpose of cryptographic primitives, a hash function is suitable in cryptography if with the basic properties of computability and compressibility, it also satisfies above three properties. So such a hash function are often called as cryptographic hash function. It should be computable, it should be compressible, and it should satisfy these three properties. Even if you see, we have a relation that is collision resistance. Uh, implies second pre-image resistance implies your pre-image resistance. The first implication is straightforward. It implies that main challenge is designing the hash function, collision resistant hash function. Now let us see hash function for cryptography. How do we use in cryptography? So here we discuss the need of hash function in cryptography. See, a hash function is majorly relies to achieve integrity of message and authentication of source. Integrity of message and authentication of source. Okay, so message authentication code, that is MAC, and digital signature are the most useful tool to achieve the message integrity and source authentication. We precisely discuss below the role of hash function in this algorithm. Okay, let us see first what is MDC. Which is called modification detection code. Hash function can be used to maintain the integrity of message here. Integrity of message. Suppose Alice want to send a important message to Bob. Alice first compute the hash value of it. Something like this. Suppose Alice, this is Alice, this is Bob. Alice has some message. What he does, he compute the hash value of this message. I'm going to write it as HM. Okay. Then he send the message to the Bob with some channel which is insecure channel. Correct. So he received the message and he sent this hash value from a secure channel. Here it is insecure. He is sending message M here and here he is sending H of M. Okay. So after receiving this message, what Bob does, he find the hash value of the message and check whether this hash value and the one which has received from the secure channel, whether both are same or not. If both are same, then integrity is achieved. That means there is no modification that has been done to the message. If it is not, then it means that there is in the channel there is some modification. They have some changed the message. Okay. So that's why it is called MDC. This H of M is called message digest. MDC is more useful to check the integrity of the own message. For example, suppose Alice writes a program in her computer. She can store hash value of the program. Later, when she again visit the program in her computer, she can compute hash value of the program. If both the stored and the computed hash value of the program are same, she can confirm that program has not been tampered or meanwhile. Okay. And there is one more type, that is message authentication code. That is called MAC. Yeah, as I told you, using MDC we can only check the integrity of message. To check integrity and authentication both, MAC is used. Just change the color. To check integrity and authentication both, we use MAC. Message authentication code is used. So a MAC is an electronic value or number or binary string depending on the specific message, and a specific secret key sent along with the message. In this case, I am having a key also, which is associated with your hash value, whereas in previous case, in the case of MDC, I was just having hash value. I was not having any key associated with it. So let me just quickly try to draw it and tell you. Suppose I'm having a message M. First I'll hash it, then I'll put it in the hash function. I'll get the MAC value. So I have the MAC value. What I'll do, I'll concatenate with hash value and the MAC value together. That means, let me see, I'm having message and MAC, both the thing. Okay, see, here my hash function needs some key also, which is secret. So key is used, then I'll be getting this MAC. Okay, so with this message and MAC, I can send it to the Bob through an insecure channel. So Bob received this message and MAC value. Okay, he'll just separate both of them. The message he will keep here, and MAC value, say, he's keeping here. What he does, he calculate the hash value with the key hash function with the key. A pre-shared key, he will be getting MAC. He just have to check whether this MAC and this MAC, whether they are same or not. If they are same, then both the integrity and authentication are maintained. Why integrity? Because if there is any changes in the message, then the hash value may not be same, correct? And authentication is because the same key whatever used for the hash value, that has been used here. This key is important. So this is the, say, Alice key. I am using the same key. That's why nobody else can do this part, correct? So this is a keyed hash function. We call it as keyed hash function. Both integrity and authentication are maintained of a message, authenticity of the message. That is, a message has been coming from the same person or not. Suppose Alice and Bob have agreed on a key K, and then this is happening. So after receiving it, if he is not able to do this hash part, because this hash part required this key also, message will be taken, and with the key you will get this MAC value. If you are using wrong key, you will get something else. So there are actually many many hash functions, and there are some limitations and all also. One is most important is this random oracle model. We'll talk about it. What is random oracle model? So in this case, the hash function can be viewed as oracle which produces truly random value. The hash function can be viewed as oracle which produces a truly random value. For each new query, that means what? For every query I'm making, it will always give me a random value. Okay. So a hash function is replaced by random oracle which outputs key bit element of key for key being security parameter of the scheme. Actually what happens here, uh, suppose I am giving an input, say some value e1 to the hash function. It will generate randomly something and then give me this h of e1, and it will store this. It will make a table that for e1 I have given h of e1, then for something e2 it will again do randomization, some random value, and it will give me h of a2. This is h of at is completely random. There is no function which is computed here, so randomly 1 2 3 or something like that. So again it will store this a2 and h of a2 and so on. Suppose at last again I am asking the value for e1, then what happens? He first check in the query from the table whether E1 has been already queried or not. If E1 has already queried, then he will give you the same value h of A1. He will not do any of the process. So if you query anything, first of all he is going to change. He is going to check in the table whether that has been already queried or not. If not, then it will generate a random value and assign it. If ak is that, so if it will just check whether it is there in the table. No, then it will generate a random value and give it to the h of ak, and again store this h of ak here, this ak and h of ak, so that next time if you query ak, then it will give the value h of ak. This is what random oracle model is. This is called ideal hash function, because this is not practically possible to all the time randomize. This is called ideal hash function. Okay, thank you so much.